Hi, good morning, everyone. Any questions before we go back to our conics? Okay, so today we go back to the ellipse that we established the equation yesterday. So ellipse. Okay, so yesterday we established the following. So equation of an ellipse. Okay, so if we have those 2 points, F1 and F2, so this is F1 and F2. And remember, the ellipse are all the points such that the sum of the distance, the F1 and F2 was a constant number, we called it 2a. So now, suppose we put F1 and F2. So suppose F1 and F2 are on the x-axis. And let us say F1, and we put 0 right in the middle. And suppose F1 is C0 and F2 is minus C0. And F1, F2 has a name. Probably some of you, of course, know it. Are called foci. And they have very nice property that we will talk about at the end. Okay, so this is my ellipse. It looked like that. And this is the x-axis. Okay. And A is this value such that if you take any point here on the ellipse, if you take any point, the sum of the distance means PF1 plus PF2 is a constant number that we called it A, that we called it 2A. And this is C. This is what we mean by C. So the equation was x squared. If you take any point here, the relationship between x and y has the form x squared over a square plus y squared over b squared equal to 1. And what is the b? The b was, so the c squared was a squared minus b squared. So that's what we did yesterday. All right, first let us analyze a little bit this equation. We're going to analyze it a tiny bit, and then we proceed. So let us analyze it. Okay, so I have this equation. That's its form. And this is my c squared. C are the coordinate. All right. So 3 things I'm going to talk about. What's the x-intercept? This is an equation of a shape, which is an oval shape. What are the x-intercept of this shape? This is C, I meant minus C, and this is a C. What's the x-intercept? Okay, back to you guys. What's the x-intercept? It means those points. What's the coordinate of that point? So how do we find them? We set y equal to 0. Y equal to 0, and then I will have x squared over a squared equal to 1. X is x squared equal a squared. X is plus or minus a. So this is a, and this is minus a. So in this equation, that's to a, that's minus a. So from here to here, that's my a. Okay. Now let's see what's the y-intercept. Okay, we set x equal to 0 in the equation. X equal to 0. And then I will have y squared over b squared equal to 1. It means that the y squared multiplied by b squared, it means y is plus or minus b. So in the equation, this is b, and this is minus b. So it means that the b is from here to here. Okay, so in the equation of the ellipse, that's the form of the equation. The a is from the center to this vertex, if you want, and it's and b is from here all the way up to here. Now minus A and A, those are called vertices. Okay, we gave those a name and we call them vertices. And the line which is connecting those two vertices will be called the major axis. Now, minus A and A are called vertices, not minus B and B. So those are called the vertices, the one right here on the x-axis. Now, the last remark I will make about that is the following. Let us note that, and I'll talk about it, let us note that in this picture here, in this picture, it means when the foci are on the x-axis, note that for this to make sense, that the A square, because C square is positive, it means A square bigger than B square. It means in this context, the A has to be bigger than B. Okay, so in this equation, otherwise this doesn't make sense or whatsoever. So for this to make sense, the A has to be bigger than B, otherwise we cannot have a C square. Okay? So that's the equation of an ellipse. And we will take up two examples. Actually, before I take up two examples, let me talk about that. In this problem, in this part A, we put the point F1 and F2 that we call the foci on the x-axis. Now we could have as well put them on the y-axis. So I could have done this picture. I can put the F1 and F2 here. And if I do that, the ellipse would look actually elongated, but this way, elongated vertically. But the equation would be the same. So let us a little bit mark that. If the foci are on the y-axis, it means are on the y-axis. So the picture right for me now is this is F1 and this is F2. And I take all the points whose distance to F1 and F2 is constant. Okay, the equation will be the same, nothing will change. So if the foci on the y-axis, the equation is always the same. The only difference is the following. So the equation would be, I will not change the shape of the equation. The equation is always the same, but in this case, the B will be bigger than A. That will be the difference. And C square will be, so A takes the role of B. That's really what's happened. And C square will be the larger square minus A square. So on the picture, this is my B. This is the C. And this is the A. Okay, and those will be called the vertex in this scenario. Those are called the vertices. All right, so let us do two examples just to basically you have totally what I want from you is that whenever you see an equation like this, immediately see an ellipse. I mean, it's crucial that you recognize the equation of the ellipse as you see it, because something that you will encounter immediately once you reach guys to 61 very soon. So example number one is the following. Find equation of the ellipse. So you have to find equation of an ellipse with foci zero plus or minus 2. These are the foci, and vertices 0 plus or minus 3. Okay, so find the equation. So I'm talking about the following ellipse. Foci, they are on the y-axis, 0 plus or minus 2, and the vertices. So these are the vertices right here, and the foci are inside. So this is my ellipse. Okay. And the question is to find the equation of this ellipse. All right, first the equation. We know that the equation is of the form x squared over a squared plus y squared over b squared equal to 1. That's the equation. To find it, I need A and I need B. What's given for me, what's given to me for free in this problem? Back to you.
B is given.
B is given. So B is the vertex. B is given because I have, this is my B. So the B is equal to 3. So B squared is 9. I'm done with this piece. I need the A. To find the A, they gave me the foci. So they gave me C is equal to 2. So that's my C right here. That's the B and that's the C. But what's the relationship? We know that C squared is the largest in this case. So here B is bigger than A because the foci are on the y-axis, minus A squared. That's my C squared. It means that I know C, I want the A. It means A squared will be C squared, B squared minus C squared, which is 9. C4 equal to 5. And the equation become x squared over 5 plus y squared over 9 is equal to 1. So that's the equation.
I have a question.
Yes, please go ahead, Chris.
How do you get the 4? I mean, yeah, the 4 for C
It's
squared.
given. It's given. That's the foci.
Oh, so we don't know A in this problem?
We don't know A, right? We don't know A.
Oh, okay. I messed that
That's
up
how we
then.
go. Yeah. That we have the foci, and I will tell you, as I said, what are the property of the foci? What's the important thing about them? Actually, what I just tell you now. So they have, the foci have very nice reflecting properties. So that's why they are important. Let's see what are the reflection properties. And some of you have seen it. I mean, some of you have really interacted with it. So suppose we have an ellipse here. Okay, an ellipse like this. And these are the foci, F1, F2. Okay, the property, one of the property that actually it is used, if you put a source of sound here, so some kind of a sound here on one of the foci, so you put a sound here, the sound will bounce off to the top of the ellipse, and then it will reflect it to the second foci. So if you put here a source of sound, it's going to bounce up, it hits the edges of the ellipse, and then it's going to bounce all the way to the second one. Now, a fun example that some of you might have interacted with it is, I know if you have been to the Science Museum, Museum of Science and Industry. The one in Chicago.
Yes.
Yeah. All right.
One time.
Yes. Yeah, of course. I've been several times. Okay, I have 2 children. Now, there is a gallery there called the Whispering Gallery. I don't know if you ever guys paid attention to it. It's called the Whispering Gallery. And what's this Whispering Gallery is about? So that's one fun example of those. Whispering Gallery is like a huge hall, a really huge hall inside the museum. Very big hall. And in one part of the hall, there is a stand with a microphone on it, okay? And there is another piece, very fast, a huge hall, and there is another stand here. If a person stand on one part of the hall, somewhere here, and whisper, the next person next to him may not hear what he said, but the person here, very far away, will actually can hear him. That's what's called the Whispering Gallery. So it's a huge house. So you imagine those are, a few miles away from each other. And there is those 2 microphones here. You sit here, you whisper. The one next to you can't hear. The one right here does hear you very well. And I've tried it several times because, as I said, my children had a kick out of it. And the idea is the following. The cross-section of this gallery is an ellipse. And if you talk here, that's one of the foci of the ellipse. You talk here, your sound will bounce and reflect to the other foci. The one here will hear you, the one next to you will not hear. So this is, if you ever go to the Whispering Gallery, to the Museum of Science and Industry and go to the Whispering Gallery, that's exactly what's going on. And the same idea, it's used, the book, actually, the note I gave you also talk about that, to actually kill kidney stones. So they use sound wave. If somebody has kidney stone and they want to destroy them, they use the idea of sound wave. It means they send sound to the kidney to basically destroy the stone. And they use the principle of ellipse to be able to do that as well. So they send, to the way they send the sound wave, so they localize the stone on one foci of an ellipse somehow, and then they send the sound wave from one foci, it will reflect and then go back, and they reflect back to the kidney, to the stone after they localize them extremely well, and they the stone will burst and they will be destroyed. So it's used in a lot of practical reasons. All right, so that's really the importance of the foci. So example number 2. Has anybody gone to the Whispering Gallery? Anybody remember those day of school when they take you to see the museum? I guess not. All right, so example number 2. Let us consider the following equation. So find, I'm going to do backward to the previous problem. Find foci, vertices of the given ellipse. Okay, all right, so x squared, I'm going to give 2 examples. The first one is x squared over 9 plus y squared over 5 is equal to 1. Okay. So when you are given, the only thing I remember that electricity thingy on the ceiling. Oh boy, whatever this is, electricity thingy. Okay, go back, Chris. You will see the Whispering Gallery. It's kind of fun. So we have to find the foci. So this is a typical ellipse. And the a here, I mean, a squared is 9. So we know what the a is, and b squared is 5. So a is bigger than b. When a is bigger than b, it means that the foci are on the x-axis. That's what tells us whether the foci are on the x or on the y-axis. So the picture is like that. My foci are right here, and the vertices are somewhere here, and this is really my ellipse. Okay, elongated this way. So now I need to find the vertices. So the vertices are those. These are the vertices, it means the a. So I need a squared equal to 9. It means a is plus or minus 3. So the vertices are, the first vertices, plus or minus 3 and 0. One vertex, that's another vertex. Okay, so those are the vertices. Now the foci. It means I need the c. So we know the c squared is the largest, b squared, I meant a squared minus 5. This is equal to 4. C is plus or minus 2. It means the foci are at plus or minus 2 and 0. So that's one foci, and that's the other foci. So that we call them basically F1 and F2.
Quick question. Where are you getting the c squared equals 9 minus 5?
That's from the formula. If you remember yesterday, we actually built it. I don't know if you remember. When I derived it, do you remember when I derived it?
Yeah, I remember it was like b squared equals a squared minus c squared.
Right, but that's easy for you to memorize. Yes, when we derived it yesterday, we set b squared to be a squared minus c squared. You remember that?
Yeah.
Right. So if we solve for c squared from this, I'll get b squared minus a squared. Sorry. A squared minus b squared.
Okay, yeah.
All right?
Okay, that makes sense now.
Yeah, thanks. Yeah, so this is what the formula brings us here. The formula did not give it that, but that's really easy to memorize, because when we're going to see the hyperbola, we're going to have another idea of a foci, and it will be easier for you to remember it this way than that way. That's why I rewrote it. Very good. Now part B, before we finish, I mean, we move on. Part B is sometimes the ellipse is not given to you in a very, very simple format like this. So suppose you have something like that. Plus y squared equal to 9. Okay, and what's the foci and what's the vertices? If the equation is given like this, what am I supposed to do with it? So I can see the foci and the vertices and everywhere, everything. So let me write here that the equation of the ellipse, sometimes what we call the standard equation.
Would you solve for each one?
No, let me
Oh.
write the standard equation. Give me 1 minute and then you guys will. The standard equation is x squared over a squared plus y squared over b squared equal to 1. Okay, that's the standard equation. But sometimes the equation will not be given in such a nice format. Okay, sometimes it will be given very close to it, but not quite. So how can I make this equation look exactly like that? Now back to you guys.
Divide everything by 9.
We divide everything by 9 because I want this to be equal to 1. Okay, so divide across by 9. Okay, and then I will have 16x squared plus, over 9 plus y squared over 9 equal to 1. Very good. We're not quite there yet. How can I write it verbatim like this? So part of it has this form. I don't have issue with that. How can I rewrite this so that it look like x squared over a squared? So I know what my a squared is. So I'm going to really write it into standard form. We can do a little bit of algebra to rewrite this so it will have the standard form. Okay? Because I want a square. What's going to be a square in my problem? It has to have this form. What's going to be the a square? All right? We cheat like this. We actually cheat. We rewrite it as, am I correct? Am I correct? Have I changed anything? Is those same? Those the same? This is going to be my a square. Now I can see it. And this would be my b squared. Question, are those two things, expression exactly the same? Nobody telling me yes? Wouldn't, oh, of course, 9 over 16. Thanks, Elizabeth. Are those two expressions the same? Yes or not? If I take x squared, I divide it by 9 over 16. Property of fraction, it's x squared times 16 over 9, which is exactly 16x squared over 9. So I mainly want to bring the 16 down here. Now I have everything. I have my a squared, I have my b squared, my problem is done. Now I want the vertices. A squared is 9 over 16. So here a, the largest one is the b. B bigger than a, it means foci on the y-axis. So this time, my ellipse is going to be like that. That's how my ellipse is going to be. And then the vertices are the b's. So I have vertices. We have b squared is 9. B is plus or minus 3. That's the vertex, that's the 3. Now I need the foci. All right. C squared is always, it's a squared minus b squared if the foci on the x-axis. If the foci on the y-axis, it's the b that plays the role of a. So it's going to be b squared minus a squared, the largest minus the smallest. It means 9 minus 9 over 16. And now I do a little bit of math here, and I will get, this is equal 9 times 16 minus 9. I think this will give me 135 over 16. It means the c is plus or minus the square root of 135 over 16. So the vertices are 0, plus or minus 3, and the foci are 0 plus or minus the square root of that, somewhere in here. That's my C.
I'm also confused now. How did it become now C squared equals B squared minus A squared then? How
Here,
did we, yeah. How did we get that?
we flip what we did in the previous problem. It's always the largest minus the smallest. First of all, A squared minus B squared doesn't make sense, because which is largest here? B is largest. So already it doesn't make sense. And if we do the same thing as we did yesterday, verbatim the same thing. Okay, verbatim the same thing. But we put the foci here. Okay, we put the foci here. And instead of whatever we did with B, we do whatever we did with A yesterday. If we redo it with the B, it means we take all the points that said the sum of the distance is 2B instead of 2A, then this equation will be the same. But whatever we had B yesterday, we're going to have N. Whenever you had A, we're going to have a B yesterday. And the equation will be the same.
Okay, so it's just like a matter of flipping it. Doesn't matter.
Exactly. No,
Position. Okay.
No, it doesn't matter. The only thing that matters is that if the B is bigger than A, the foci would be on the y-axis. That's what we should know. And in this case, the equation for C squared would be the largest square minus the smallest square. Just flipping, the A and flipping the concept of A and B. And
I have a question.
book, honestly, some book will rewrite it when the foci are on the y-axis. Some book would rewrite it like x squared over b squared. But I don't want to do that. I think it's confusing. Go ahead.
Wouldn't the foci be, would the foci be plus or minus square root of 135 over 16 and 0?
No, they're on the
Because
y-axis. They're on the y-axis.
oh, okay.
When B is bigger than A, B is here 3, right?
Yes.
And A is 3/4. If B is bigger than A, then the foci will be on the y-axis.
Oh, okay. All right. Sorry
Right?
about that.
No problem. And as I was telling your classmate, I write both of them, whether it's on the y or the x-axis, I write them the same format. X squared over A squared plus Y squared over B squared. And then A bigger than B, foci on x-axis. B bigger than A, foci on y-axis. Okay, that's the way I'm writing them. And I think that's the way the notes I gave you write them. Some book actually will change. They put x squared over A squared plus Y squared over B squared if the foci on the x-axis. And then they change for the y. They put x squared over B squared plus Y squared over A squared equal to 1. I don't do that. I write the same equation, but I emphasize which one is bigger than the other. All right, part 3 is shifted ellipse. So what we did now is we took ellipses, so shifted ellipse. Okay, what's the idea of shifted ellipse? What if you take a regular ellipse, those ellipse, this one. Okay, so this is the minus a, the regular, but you shift it so that you shift it horizontally and vertically, so that the center become a point here. So that's really the center. So we're going to change the center. This is H and K, so we're going to make the center, but everything else is actually the same. So everything else, I don't change anything. I just really shift it. I'm not going to stretch it or shrink it or anything. So we shift it. So we got that. So it's the same A and the same B. But definitely the equation will be different here. Okay, definitely the equation will be different. So what's the shifted ellipse? The equation become is instead of x, it will be x minus h squared over a squared plus y minus that like in the circle over b squared equal to 1. Okay, so if we shift the ellipse, we shift this to the center is HK, that will be the equation. And then again, it's the same thing. If A is bigger than B, if A is larger, the foci will be on a line parallel to the x-axis. If B bigger, the foci will be on a line parallel to the y-axis, somewhere in here. Okay, so let's do a few examples to actually elaborate this idea. So here we are. Okay, so example number 1. So it's the same as the regular ellipse, but we're actually shifting. So we're going to use the same principle in doing every one of those. Example number 1, find center, vertices, and foci of the given ellipse. Okay, so I'm going to give you an ellipse. You have to find everything. So x minus 2 square over 4 plus y minus 3 square over 9 equal to 1. Okay, so this is basically the ellipse. So in your mind, this is actually the following. That's the following ellipse: x squared over a squared plus y squared over 9 equal to 1. That's this ellipse shifted so that the center changed. So it's this ellipse what you're going to be shifting. So what is the center here of the new ellipse? The center is going to be 2 and 3. So it's this ellipse shifted so that the center is 2, 3. Okay, now I need to find the vertices and I need to find the foci and everything. All right, so let's see how we do that. So here, my A is the 2, nothing has changed, and my B is equal to 4. So if we sketch it a little bit, and then everything we get it is from the sketch. I'm going to sketch it, and then everything will be doing, we'll get it. The center is at 2, 3, 2, 3, that's the center. A is smaller than B, so we know it's going to be elongated like that. Now, A is 2 and B is 3. A is 2, it means you have to go down 2 units from here. Sorry, 2 units and 2 units. This is my A is equal to 2. My B is 3. So I need to go 3 units up and 3 units down. That's the B. So that's my ellipse, basically. Okay, this is my A and this is my B. And now we have to find everything else. What's going to be the vertices? So that's the center. What's the vertices? These are the vertices. So what are the coordinates of the vertices? And then we're going to find the foci. Okay, what are the coordinates of the vertices? Just look at the picture. What?
It's 2, 0, and 2, 6, right?
2, 0, exactly. 2, 0, this one. And this one up here, which is a 2. If this is a 3, this here to have to be a 6. So it's actually just, you're taking the regular one and you're shifting everything else. And now for the foci. First, you have to compute c squared. C squared is the 9, the largest minus the smallest, which is equal to 5. It means the c is the square root of 5. So in the picture here, where is the c? The c is right here. That's the square root of 5. And the other foci is down here. So that's going to be the foci. What's going to be their coordinate? Just look at the picture. There is nothing really harder than that. It's right here. I need this point and I need that point. This is a 2, x coordinate. Now what's the y coordinate? That's a 3. You're going to add square root of 5 to it. That's a 3. You're going to take away square root of 5. Okay, so it's 2. 3 plus square root of 5, 2, 3 minus the square root of 5. So you just basically draw the picture, and then everything else will be, will be clear. Question before I move on. Okay, example number 2. So I would like to do 2 more examples. Example number 2 is the following. Okay, find the equation. Find equation of the ellipse with foci. I'm going to give you the foci now. 2 minus 2, 4 minus 2, and vertices 1 minus 2 and 5 minus 2. Okay, so we need to find the equation of the ellipse. First, let us see what is the equation. The equation is, that's of course not centered at the origin, that's the equation, general equation. Okay, and what we need to find the center, we need to find A, and we need to find B. So let us a little bit draw something to start understanding, interacting with those given. Okay. So here, the foci is 2 minus 2, 4 minus 2, 1 minus 2, 5 minus 2. It means all of them are on the line y equal minus 2. So everything is right here on this line. So we're going to have basically A bigger than B. So the vertices are at 1 and minus 2. So this is my 1 here, minus 2. My vertex is here. 5 minus 2. So 1, 2, 3, 4, 5. So that's 5 minus 2. So these are my vertices. And my foci is 2. So 1, 2. So that's the foci in here. And 4. So these are the foci. Okay, so this is my, I don't know how it look like because I don't know B yet, but at least I know this is my ellipse up here. Okay, so the center has to be right stuck in the middle. That's where it should be the center. So I have the coordinate of the center. So this is a 2, this is a 4. So what's the center? Just look at the picture and tell me what's the coordinate of the center. So it's halfway through. So that's a 1, that's a 5, it's right here, that's the center. So what are the coordinates? Just by looking at the picture, nothing deeper than that.
3, -2.
3, -2. I have the H and I have the K, all right? Now what's the A in this problem? A is how far is the vertex from the center? That's your A. Okay, so what's the A?
2.
2. We're done with A. Now I need the B. Look at the B, I need the relationship. So we know now I need the B. So I have A done, now we need the B. Okay, what do we know? We know that C squared is B squared. No, sorry. In this case, is A squared minus B squared. Means my B squared is A squared minus C squared. But what is the C in this problem? These are the foci. This is my A, and this is my C right here, because C is nothing more than the foci. So the foci, but C is equal to 1 in this problem. So B squared would be A squared, which is 4, minus 1 equal to 3. And the equation would be X minus 3 squared over 4. That's
I have a question.
Yes, I'm listening.
How'd you guys see?
It's given to us. From the picture. Look at the picture very carefully. Okay, the foci is 2 minus 3, 4 minus 2. Okay, so if you draw the line here, basically I'm thinking along this line. If you draw the line, so this is the vertices at 1, if you want, and the vertices at 5. Okay, and the
Yes.
foci, so that's the center, and the foci are at 2 minus 2. So if you think of this is the 2, and this is the 4 right here. And that's the center. The foci is here. This is the C.
Oh, okay.
You see it?
Yeah. So 3 minus 2 would be 1. And 4 minus 3 would be 1.
It's basically half the distance from here to here.
Oh,
From here
okay.
to here, you have 2 divided by 2. So you can look at it in a different way. Is it half the distance between the 2 foci? That's one way you can think about it. Or once you find the center here, which was a 3, it's from the center to the foci, which is a 1. So those problems purely do them looking at the picture. I mean, there is no other way. Just look at the picture and figure them out. Plus y plus k. My k here is 2. No, so my k is minus 2. So it's gonna give me y plus 2 squared divided by b squared, which is a 3, equal to. That's the equation of this ellipse. Okay. One more example of the ellipse. And sometimes the ellipse will be given to you, but in a very disguised format. It means this is the standard format. It will not be given to us in this nice standard format. It will be given to us in a slightly disguised format, and we have to do something called complete the square to be able to do it. So here is my example. Okay, find the ellipse. So find center, and what else? Vertices and foci of the given ellipse. So I'm going to give you an ellipse now. It doesn't look at all like an ellipse. It looks like it has nothing to do with it, but we have to make it into an ellipse. So here we are. X squared plus 4y squared minus 8y equal to 0. Okay. So you look at it and you say, you know, but this is not what you told us. This is not what the equation. The standard equation of the ellipse is the following. X minus h squared over a squared. That's the standard format. Equal to 1. Okay, that's the standard format. So how can we take that equation and put it in the standard format? How can we rewrite it so it will be in this form? Okay, so we're going to do something complete the square that we've seen before, but we're going to apply it to that. So how are we going to complete the square? I want this to look like that in a way. All right. The way you proceed is x squared is actually completed in a way that is nothing to do with that. Now it's this expression that I need to complete its square. Now let me remind you how do we complete the square. In general, if you have an expression of the form, let us say y squared, the coefficient of y squared is 1, that's important, plus a certain by. And you want to complete the square. Do you remember what do we add and what do we subtract? You must have, because that's we've done this for the integration. What do you add and what you subtract to complete the square? We take what's y multiplied by, divided by 2, and we square it. If we do that, we get this expression square. So that's how we completed the square. And that's what we're going to do right now, because I'm aiming for something like that. All right, the way we're going to do it is like this. The algorithm we've learned works as long as the coefficient of y squared is 1. So to prepare for it, I'm going to first factor out the 4. And I will get y squared inside minus coefficient of this, which is 2y. Okay. Now, this is x squared plus 4 times. I need to complete the square of the expression in here. So how do we complete the square? It's y squared minus 2y. What should I add? Quickly, guys, you should know that.
1.
1. But if I add 1, what should I do?
Also subtract 1.
We have to subtract 1. If I don't, I'm in trouble. I'm changing my expression. All right, we add, we subtract, so we keep things balancing out. And now we are actually almost done, because let's see what we get by but the only thing I'm doing is rewriting. I'm really playing a simple game here. Okay, let's see what we get here. This piece here, okay, that will become y minus 1 squared minus 1 equal to 0. Okay, and now I just distribute. I will have x squared plus 4 times y minus 1 squared minus 4 is equal to 0. So I will completing the square to let it look like a standard form. So this will give me x squared plus 4 y minus 1 squared equal to 4. Now I am very, very close to the standard format. The last piece we're going to do is we divide by 4. If we divide by 4 across, because I want it exactly like the standard form, I will have x squared over 4 plus y minus 1 squared equal to 1. And this is, in honest to goodness, ellipse in the exact standard form. We have to do it. So the idea is we have really a lot of times, actually, the equation will not be given to us as an ellipse. It will be given to us in this format. And we have to play around with it. So we have to, it will become actually the equation of an ellipse. And sometimes equation of a circle. You know, a lot of time this will lead me to a circle. So now the center. The center is easy at this stage. It's 0 here. And it's a 1. Now in this problem, my a, or a squared if you want, is a 4, because that's the a squared. Now this is divided by 1. It means my b squared equal to 1. So I have a bigger than b, which is always guide us. So now let us find the center. So here I will draw the picture a little bit, and then we can find everything. 0, 1, 0, 1. So that's the center. A squared is 4. It means a is 2. So I need to go 2 units this way and 2 units that way. So that's my a, 2. And my b is 1. So I go 1 unit up from here. That's the b. And I go 1 unit down. So this is, so the center is 0, 1. So this is 1. So I'm going to go like that. But that's really my ellipse. Right. So now what's the vertices? The vertices are those 2 points, because that's the longer axis. These are the vertices. So the vertices, you have 2 vertices. This is the 1. So the x to y coordinate is fixed. And now this is going to give me 2 here and minus 2. Okay, that's the vertices. Now for the foci, first I need to find the c. Now here the c squared is the largest minus the smallest, which is equal to 3. And it means the value of c is the square root of 3, but the foci are. So the foci will be right there and right here. This is my c, which is the square root of 3. So my foci will be, so we have 2 of them. It will be 1 is the y coordinate and square root of 3, or minus the square root of 3 and 1, and of the problem. Okay, so quite often the ellipse, the equation will not be given to us in this very nice format. It will be given to us in another format that we have to rewrite it to become like that. Okay. Now, the last note is about ellipse versus circle. So the equation of the ellipse is x squared over a squared plus y squared over b squared equal to 1. When the ellipse is a circle, under what condition on A and B, you think? Under what condition on A and B, the ellipse will become a circle. Ellipse, you can think of it as a circle being smashed a little bit.
Is it when they're equal?
Exactly. So if A is B, if A equal to B, then the ellipse is a circle. And basically, in this case, the foci become the center of the ellipse. So basically, the idea now is that the foci will actually all collapse to the center. But when A is B, then this is a circle. So the ellipse is actually a circle when those two are equal to one another. Okay. All right, so I stop here today. I didn't go over time, and I will put the assignment on the announcement page. As I said, for the ellipse, I will assign the assignment. So you guys do them and ask me questions about them tomorrow. So I will put them on the announcement page, the problem that I want you to do. And what we still have is hyperbola. Tomorrow, we're going to talk about the hyperbola. And it will be the end of the course. All right. Any questions before I let you go?